All right, good evening. Glad you could join us here tonight. I'm Carla Whitmore. I'm an enrollment counselor here at Union, and I'm here with Mr. Brent Page. He is the computer science and math program director, teacher.
Extraordinaire.
Sure. He's usually in a different department than I am, so I don't usually get to hang out with him, but we're here tonight doing the Zoom so you can learn more about science. Just to remind you that there is a $500 scholarship that you can get tonight for joining the Zoom. So just, I believe most of you could type your name in the chat because sometimes the name that appears on your Zoom account is not always the correct name, or their nicknames or something. So just type your name in the chat for me, and then we will make sure that gets added to your student account when you come here in August at registration day. There's also recordings of past Zoom sessions that we've had with different faculty, and you can find that on the website. So Brent, he will have time for questions during the end, or if it's sometime during the middle or you have a question, you can raise your hand. Feel free to type something in the chat. I'll be monitoring the chat on the backside. And Brent has no problem engaging and talking to students at that time. The time is yours, Brent.
All right, excellent. Well, the pressure's on. So again, welcome everyone. Thank you for taking time this evening to tune in. Definitely we'll have time for questions. If there's stuff as we go along and you have a question, just let me know and we'll be happy to discuss into it further. One thing that I like doing is just getting to know each other just a little bit more. That way I can kind of customize what we talk about to be more toward the direction that you're interested in. Don't worry, I'm not going to make you do like an introduction or anything like that here on the Zoom. But just if you do like a thumbs up, thumbs down, or something like that on answering a few of these questions, it'd be okay. How many of you are interested in the computer science programming aspect of computing? All right, so we have at least one person. How many of you are interested on the network servers side of things? And then there's probably the third option, which is the majority of people. How many of you are just interested in just learning more about all of the above and what you can do with it, etc.? All right, excellent. And then the last one, how many of you actually play sports or a musical instrument? Yes, no? Yes, kind of, no? Okay, excellent. All right. I am the program director for computer science and math. And just a little bit about me. I worked in IT for 21 years before I took up this teaching position here at Union. So I graduated from Union in 2000, which may seem like a really long time ago, but trust me, time is going to go by really fast. To put that in perspective, a high-speed internet connection was 1.5 megabits per second. Today, your home connection, or at least my home connection, is 500 megabits per second. So just a little bit of difference between now and then. I worked in IT, as I said, for 21 years. Much of that was as a IT director. So all things for the organization, IT, ultimately my responsibility to put my name on the direction that the company was going, whether that was the new servers we were going to get, the new software that we were going to get for the organization, etc. I enjoy sports. As I'm getting older, it's more of the less fast, twitchy sports. So, you know, basketball is not something that I am that good at anymore. Maybe free throws, but not actually, competing with youth. But cycling, that's a lot of fun, camping, etc. And then this is a picture of my wife and I from our trip to Hawaii a few years ago. So what can you do with a computer science, information technology, or mathematics degree? One thing that I find is that that's kind of an unknown for many people. They're kind of like, well, I think I might like computers, or I like using computers, but I don't know what I can actually do with computers. There is a slight distinction between the way the IT industry approaches things and the way academia approaches things. So on the industry side, we'll call IT basically any of the careers that can fall under computing. So that's programming, networks, servers, web development, et cetera. All that kind of falls under the industry term IT. On the academia side, we start getting a little more picky and we say, okay, computer science, that's more on the programming side. Information technology, that's more on the network server side, etc. So we're going to dive in. These are all career areas that are pulled from the government's Bureau of Labor and Statistics website. These are all areas that our degrees here on campus can help prepare you for. And then as we're going through the different type of career areas, I will explain a little bit more about how we can prepare you for those fields. Data scientist. How many of you have heard of ChatGPT or any sort of AI? How many of you have used ChatGPT or some sort of an AI piece of software? It's not a trick question. While most college professors and high school professors probably wish people would not use AI for doing things, in IT, it's inevitable. You know, it's like we're looking to figure out, well, how can we use this better? When I was graduating, the new exciting thing was the web, which I know sounds really funny, but that was the new exciting thing. Internet connections were finally getting fast enough. And as a result, you could start doing things on the web that you couldn't before. Amazon, they got their start right about the time that I was graduating. Google, they actually started when I was a junior. And look at where those organizations are today. AI has the chance to change that playing field, just like the introduction of the web did before. That's why you see Google, that's why you see Amazon, that's why you see Microsoft, that's why you see OpenAI, that's why you see all these organizations dumping so much time and resources into that area because of the change that could impact on the industry. We have a little logo here of NVIDIA. They have been the right company at the right place at the right time. I checked here this evening. They are worth $3.09 trillion as of their stock price closing today. That is way more than they were at the start of 2023. So in 18 months, the company has more than quadrupled their value, according to the stock market. Data scientists, that field is expected to grow by 35% by 2032. And the government's numbers are always a little bit, check back next year to see how it's going. Because if you were to look 3 years ago, data scientists were not going to be growing this fast. But now with AI, it seems like everywhere you go, there's something with AI. Your doorbell that didn't have a label saying it used AI suddenly now is using AI and you did nothing different. I'm surprised they don't have cereal boxes saying, Honey Nut Cheerios made with AI. But, it's the hot marketing buzz term, et cetera. So 5 years ago, you wouldn't have seen data scientists growing by 35%. But today, yeah, it's growing fast. So what do? You use analytical tools and techniques to extract meaningful insights from data. You're also, especially if you're on the AI side of things, you're going to be creating algorithms and mathematical models that power all of these pieces of AI. You're also going to be looking at, how do I find useful data for projects? So there's different areas as a data scientist you can go into. Generally, you're going to need a strong mathematics background and you're going to need a strong programming background. But definitely you're going to need a strong mathematics background to proceed farther. A lot of times you're going to need to look into a master's degree also, because on the mathematics side, you really have to have a very solid foundation to start diving into the definitely above my pay grade and expertise, mathematical models to make those pieces work. Right now, the data scientists, they're at the bleeding edge of business. Companies can't hire enough people for the data scientist role to do their AI models. And that trend is probably going to continue for at least the next 5 years, 6 years, as all the companies battle it out to see who has the best product. Information security analysts. How many of you have heard of ransomware? So kind of, sort of. Has anybody heard of the ransomware issue? There is an auto company. Well, I shouldn't say it's an auto company. It's a company that creates the software that automotive dealerships use to sell vehicles, schedule service appointments, etc. And they recently got hacked and ransomware, and it took down at over 16,000 auto dealerships in the United States. To my knowledge, they still are not up and running yet, and they're still looking at paying the ransom. So with information security analysts, basically you are protecting your organization's digital footprint. So you plan and carry out security measures to protect the networks and the systems. This field has been growing very fast since 2017. That's when ransomware first came on the scene. And for those of you that are not familiar with ransomware, that's where an organization will hack into your system. Generally, it's through somebody clicking on a link or an attachment in an email. They will then start escalating their privileges within your network until they can get to an administrative level of access, in which case they then encrypt all of the contents on your network. Once they do that, you will get a nice little message on your screen if you try to log into your computer that says, sorry, all your data belongs to us. And if you pay this amount of money in Bitcoin, we will give you a decryption key that will let you get your data back. Now, raise your hand if you think that that decryption key works. So the decryption key that you're going to pay for, how many of you think that it will work? How many of you think that it will not work? Okay, so definitely more people think it will not work than work. Surprisingly, most of the time the decryption key works. And that's because they have way too good a business going on, so that if somebody actually started sending out bogus keys and they didn't work, then people would quit paying the ransom. And then literally the hundreds of millions, even billions of dollars that are being paid in ransoms would dry up. So it's in their economic interest to keep the decryption keys working. For us on the computing side of things, it makes life entertaining. And no, ransomware is not what accelerated my hair loss, but it is something that keeps most IT security people up at night. Because again, it is the end user many times that causes the problem. Not necessarily all the time, but email is a big possibility. Also, if you have your users that you haven't deactivated yet, and they're just sitting on your network, and somebody can try logging in with stale credentials, get access that way, etc. So what do you do as an information security analyst? It kind of covers, a wide range on the IT side. It's, making sure your organization has proper password policies, people have the proper training. Do you have the software set up in place to monitor who's getting access to your system, what time, etc.? It used to be that you would have antivirus that would run on your computer, and if something bad happened, it would stop it, let you know, etc. Well, now things are based on behavior. So if the system learns, hey, Brent works 9 to 5 Monday through Friday. Why did he log in at 3 a.m. on a Sunday morning? Well, that's already suspicious because he never does that. And why did he try running these admin level commands? Well, that's very suspicious. We're going to actually lock this down. That software will then contact a human, and then a human can start looking into the issue and go, hey, do we have a problem here or not? Penetration testing. So this is legal hacking. And I always bring up in all of my presentations, the difference between legal and illegal hacking is if you do not own the system that you're trying to gain access to, then it's illegal. So take Gmail, for instance. You do not own that system. Even though you have an account on it, you don't own that system. So if you try to do a penetration test on Google, you could go to jail. If you have your own little server set up in your room and you're trying to test the security on that server in your room, you're probably okay. So again, unless you know exactly the legality around it, just always remember unauthorized computer access is typically considered hacking. Even if that's using your friend's username and password to log into their account, that could be considered hacking. So penetration testing, that's where an organization hires you to try to test the security on their systems. Due to ransomware and companies giving insurance to make businesses whole if they get ransomware, they now have to do yearly audits to make sure that their security is where it needs to be, and that's where penetration testers come in. Mathematics and statisticians. This is a big growth area, projected 30% between now and 2032. And it's, as you might think, it's numbers heavy. So you're analyzing data, you're applying computational techniques to solve the problems. Many times that could be finding data for experiments, that could be creating statistical models. Economists will also, fall into this area. Definitely analyzing the data to determine, well, what is relevant and what is not relevant for what we're trying to do. This is somewhat similar to the data scientist, but a data scientist also has a solid understanding on the computer programming side too. Software developers, and I want you to keep this one in mind because we're going to talk about the difference between a software developer and a programmer here in just a few moments. But basically, a software developer is you're designing computer applications or programs. This is a more people-focused position. You're going to many times work with a client to find out, well, what are their needs? And then you're going to design and develop a solution for those needs. It might be an app for their phone. It might be a web app for their entire company. It might be an inventory system. Whatever it is, you're going to be working with them to spec out and develop what the solution would be. You're then going to work with programmers to actually build that solution and ensure that it's built to meet the requirements for that project. It's kind of like the idea of a contractor. If you're going to have somebody build your house, and then the contractor works with the subcontractors. So the contractor doesn't necessarily put the plumbing in, but he hires somebody to do that. He doesn't necessarily frame the house, but he hires somebody to do that. And the contractor hires somebody else to do the roof. But from the individual standpoint, the person buying the home, they are working with the contractor. Same idea with software developers. The software developer is that middleman, or I should say, they are that point of contact for the customer, and then they'll take those needs, convey it to the programmers to have the solution built. That's kind of software developers in a nutshell. That does not mean software developers do not know how to program. They definitely know how to program. They've just advanced further along the lines of working directly with the customers. Actuarial science. Do we have any math majors or prospective math majors online? I'm not seeing any thumbs up. We'll just briefly talk about it. So actuarial science, basically our bullet point here, car accident versus hit by lightning. An actuarial scientist would be able to go start juggling the numbers, running their different mathematical models to determine what is the likelihood of me getting hit by a car accident and what is the likelihood of me getting hit by lightning instead. So they're going to analyze the data, figure out the probability, and then the important piece is the cost of that event happening. So that's why your car insurance has a certain price. A younger driver has higher insurance because they're statistically more likely to get involved in an accident compared to a driver that is maybe 30, 40 years old. Now, granted, once you get to the other end of the scale, it starts going up again, like when you start getting into maybe your 70s and 80s and you're driving, because again, the probability of a wreck goes up. And so an actuarial scientist is able to take all of that information and figure out what the cost associated with that risk is so that, let's say, an insurance company can charge the correct amount for insurance and not go bankrupt. You'll see this in financial analysts, accounting, data science, and other fields too. Web developers. So I'm wanting to make a distinction between a web developer and a web designer. So a web developer, we're looking at building the product, not necessarily how it looks. So a web designer is going to focus a little bit more on the how does the site look, how does it feel, what do the graphics look like, etc. The web developer is going to implement that design, so doing all the coding. And on the web developing side, we have what's called front end, back end, and full stack developer. So the front end is designing what can be seen, and typically that's what runs on your computer. So when you go to a website, you click on drop down menus, etc. That's most likely running JavaScript or some equivalent, and it's running on your computer. But when you log in and it queries a database, well, that database is on the back end. So you can have a career as a front-end developer, as a back-end developer, or if you can do both, then you're considered a full-stack developer. We have a lot of classes that focus on both. So you can do front-end, you can do back-end. So you're going to have an idea of how to do full-stack development by the time you're done. Network and computer system administrators. So this field is kind of plateaued right now. The government doesn't say it's going to lose positions. It's not saying it's going to gain a whole ton. It's just kind of plateauing right now. Part of that is due to AI. So it's hard to make a projection as to what's going to happen because, is AI going to eat into this? Something that's important to note is that that doesn't make this career path irrelevant. This is your first stepping stone to bigger areas in IT. And that's one thing that I want to stress is that we want to make sure that you have a very solid foundation so that wherever you go in your computing career, you'll be prepared for that. And part of that is knowing how and being comfortable self-teaching. Because as flattering as it would be for me to, every 4 or 5 years when a new version of Windows shows up and I swing by and give you a quick primer on how it all works, that's not what is going to happen. But if you're working for an organization, they're probably going to say, hey, Brent, you're in charge of servers, the new versions coming out. We need you to become the expert on that. And so we make sure that you have that solid foundation so that those type of challenges, piece of cake. So with network and computer systems administrators, these are the nuts and bolts. It's like building a network, building a server, deploying those systems. Something that is very prevalent now is virtualization. So instead of having a physical machine that you're setting up, you may set up a virtual machine, especially a virtual machine in the cloud. So for instance, if you use a Google account and you have Google Sheets, Google Pages, all those different things, that's on the cloud. That's running on virtualized servers that are running those specific applications. And in fact, many organizations are moving heavily toward virtualization. And so many of the classes I teach are now focusing on that. And you have lots of different avenues that you can go. So it's like once you have a solid networking path, for instance, I have friends that make 6 figures as tier 3 network engineers. They really like networking. And I'm like, awesome. That's not exactly what I enjoy, but they do, and they do very well at it. Same thing with systems administration. You can make a great career out of that, making sure the servers are working and all of that. And then computer programmers. So basically at its core, a computer programmer is writing code that's going to do something. It might be a complete program that runs on your computer. It might be something that runs on a server, and so it's a web-based program. It could be, just a small snippet or a script, but that is the entry point for, getting towards software development. Many times computer programmers, they may or may not have to work with the client, which some people really like that. It's like, hey, I really don't want to deal with people. Let me have this job. Let me go sit in a nice quiet corner, put my headphones on, and I'll just, rip off, 500, 600 lines of code per hour, call it a good day and go home. So that's awesome. And even though computer programmers, they're projected to decrease just a little bit, there's more people employed in computer programming in the US than most of those other career paths that we talked about combined. So if you're looking to have a variety of locations that you could work, or especially remote, then computer programming is where it's at. And again, with computer programmers, as you develop your skills, that then starts opening up the more people-oriented positions, like a software developer. And, if that's what you enjoy, awesome. If you would rather not, most of these positions, if you push yourself toward the top of the skill set in that field, you're easily going to make six figures. Starting off, you're not going to start off at six figures. If so, I would probably be, putting in my resignation tomorrow, much to my boss's chagrin, and saying, hey, I'm going to go make more, being an entry-level programmer. Now, some places you can start off really good, but a lot of the big companies like Google, Amazon, Facebook, they used to be in competition with each other to literally just see who could hire the most programmers. And over the last few years, they've been starting to shed some of those workers. So most of the declining computer programmers are from the really big organizations, not from your smaller organizations in a lot of the other cities. And there's other career paths, but these are just the main ones that I wanted to highlight. So again, the degrees that we specialize in, computer science, that is going to be our programming. So by the time you're done with computer science, you're going to have a good idea of how to do front-end programming, back-end programming, and even a standalone program that's not web-oriented. Information technology, that's the area that I teach a lot more of. Gary Dickerson, he's the one that teaches more of our computer science classes. On the IT side, we're doing networks, we're doing servers, we're doing virtualization, and we try to make it fun. Like you can kind of see in the background, we have a lot of network equipment here in our classroom. One thing that's really nice about it, we are quarantined from the rest of the network. Well, I shouldn't say that. We're mostly quarantined from the rest of the classroom. We had a LAN party last year, and we actually froze up the college's network because we were downloading too much data. Who would have thought that over 0.5 terabyte of data in 3 hours would clog an internet connection? But hey, otherwise, we're mostly quarantined from the rest of the network, which is nice because that allows us to build stuff, test it. If it breaks, it doesn't hurt anybody else. We have a mathematics degree, actuarial science degree, and math education. One thing that we are doing this summer, and we'll have the process completed by December, is we're doing a program review, and we are shuffling around some of our classes. So the degrees are going to remain the same on the computing side. We're still going to have computer science. We're still going to have information technology, but the components or the classes are going to change just a little bit. Like I said, I'm now pushing more toward virtualization, especially in the cloud, like with Microsoft Azure, and incorporating more AI into our classes because you're going to be using AI when you graduate. Since I come from industry, I have a passion for making sure we can do things. Like when I hired people to work in my department, yes, I cared about what they said they could do, but I was really interested in what they could actually do. And that's the way I look at our classes also. It's like, we're going to have lecture. The fact that I'm having to stand here and talk for 30 minutes tonight, that hurts just a little bit because I usually don't do that in my classes. I like covering the high points, covering the complicated pieces, and then let's actually use it. Let's actually do it. In our networking class, one of our first class periods, we're actually building network cables, punching them down, testing them, making sure they work. Are you going to do that for a career? Probably not, but you may really like it. But at least you'll know how that works. And so then we can move to the next piece, which is like, okay, now we start connecting everything with all these network cables. Well, what if it doesn't work? Now we can figure out how to fix that. Set up and deploy physical and virtual servers. Like we have this server right here. That one is one that we use in class. We have some in the back that some of those are available for use in class, and some of them run pieces that we use in class. And when I say, available for use in class, we're letting the students, that'd be you all, actually play around on the server. So for instance, one of the final projects was they had to install Windows Server 2019 on that machine and set up Hyper-V. And one person asked, well, what if we do it wrong? I'm like, well, then it's only another 2 hours to try reinstalling it and, setting it up. So it's that ability to try it out, break it in an environment to where you don't have to stay up all night to fix it. There's times that I messed up in previous jobs where I'm like, oops, I broke something. The business opens by 8 a.m. in the morning and I have to fix it by then. Well, we can simulate those type of learning experiences without the economic repercussions of, all of your doctors not being able to see patients until you fix the mistake that you made. And so we create opportunities to just, get your feet wet and learn how those pieces work. You're going to be able to develop applications. You're going to be able to develop and use lucrative soft skills. That is a secret, or I shouldn't say secret, that is a fancy way of saying develop your people skills. Interacting with other people, that can be awkward, that can make you feel kind of vulnerable. It is profitable though. The better that you're able to communicate with other people, your clients, your bosses, other organizations, the more valuable you become. And so in our classes, we emphasize that. So it may be group activities. It's like, well, what do you do if a group's not providing what needs to be done? All right, let's talk about that. Because when you get in the workforce, you may ask a department, hey, I need X, Y, Z for this project, and they may not do it. So then how do you handle that? And so having those type of interactions in class, they can be translated to the workforce and help you in your career. Also this last year, since we've had it multiple years in a row now, we've been doing a LAN party to close out each school year. Last year we had, I think it was close to like 25 students, and as part of the final project, one of the networking classes had to actually put together the network that the entire LAN party worked on. So people brought their computers in, people brought their Xboxes, PlayStations, TVs, etc. And I provided the pizza, and then we played video games until, what was it, like 5 o'clock to 11 o'clock. I know that the competition recently has been how late can everybody stay to see if I'll actually fall asleep or not during the LAN party, but so far I have stayed awake for all of them, so they'll have to try harder next year. I did not see the question. Let me see. Chat. So the question is, could computer science fundamentals or fundamental info help build a better understanding of server and or game design via code like Python or game engines? Yes. So from a computer science standpoint, you're going to learn programming, and a lot of programming is based on logic. So how do the different pieces work? One reason that I'm passionate on learning how to learn is that, let's say you know Python today, and you go and you work for a company that uses Python. Awesome. In 3 years, you find another company, maybe it's in a town that you're more interested in, etc., but they use Java instead of Python. Well, they need a Java programmer, so you're going to need to learn Java to then apply for that position. But the fundamentals of how programming works is relatively the same from one language to the other. The syntax, or how it's typed out, is different. So for some, you may have to declare a variable a certain way. For instance, some may care if it's uppercase or lowercase. Other programming languages, they won't care. But the fundamentals of how the variable is used remains the same. And so, yes, computer science fundamentals definitely helps you build better programs. Understanding how servers and networks work would help you build better games that use server and network resources. Because if you have let's say I write Brent's Awesome Game version 1. And when it runs perfect. There's no errors, but it uses 25% of the server's resources. And then you come along with your awesome game version 1, same game, but you programmed it better and it only uses 10% of the server's resources. Well, which one's the better product? They both work. They both do the job the same. But obviously the one that uses fewer resources is better. So as you have a better understanding of how it works, especially the fundamentals of programming, that allows you to build more efficient code, which allows you to write better programs. Hopefully that helps answer some of those questions. And we're very interested in your success. We help you land internships. We have academic advisors to provide individual coaching to help you succeed in your coaches or courses. And we have the people, facilities, and resources to maximize your talent. The question is, are you willing to put in the effort to also maximize your talent? We're like a coach of a sports team. We can put together a training plan, we can put together the drills, we can pull in the knowledge, the data, etc. But it takes the participation of the team and the individuals on it to reach those goals. All right. Any additional questions from anyone? The time is yours.
I have a question.
Yes.
What is like the switch from IT to computer science? Is that like, or back and forth? Is that just mostly like programming or like math, or how would that like be? How would that look like?
Yeah, good question.
Or
so generally, and we have our classes designed our freshman year to give you an introduction to what programming is like and what some of the non-programming classes are like. So for instance, your first semester, you'll take Introduction to Programming. We've traditionally used Python. I know that Gary is evaluating if he wants to use a different language this year or not. But traditionally it's been Python because it's a relatively easy and standard language to learn, to start learning those fundamentals. And then second semester, we have Introduction to Networking and Servers, and that's a class that I teach. And so you'll start getting an idea of what it's like to deal with networks, deal with servers. What people will typically find out is that the first split in the road, as far as people's interest, is, do I like programming or not? That's kind of the divide. It did not take me very many classes to realize I did not like programming, but I did really like servers, networks, building computers, making it all work. Now, from a professional standpoint, there's nothing preventing you other than time and effort from being an expert in both. It's possible. Just generally, people will find that they prefer one over the other and specialize in that area. So, as far as your freshman year goes, let's say you start off computer science and then you say, nope, I'm really interested in IT after taking those classes. No problem. It's a pretty easy switch without losing any time. Or vice versa, if you start off on the IT side and switch over to computer science, same thing.
Okay, cool.
Yeah, great question.
All right, I have everyone's name that has joined here. Brent Page's email is in the chat, and these will be on, these should get uploaded to the website for viewing later if somebody else wants to view it or you want to watch it again within a couple of days. So any questions, you can direct them towards Brent or towards myself or whatever, and we can get you in touch. So have a good evening.